relationship depends on a productive footing.
Good news for drivers. Gas Buddy's Patrick DeHaan tells CBS News he expects gas prices will be cheaper this year.
Between Halloween and Thanksgiving, that's usually when we see the lowest price for the season, that we could see the national average below the $3 a gallon mark.
According to AAA, national average for a gallon of regular today is $3.52, down from $4.77 a year ago.
This is the wiring diagram for the Atwater Kent 10, and I've had some questions mainly about the detector. So we're going to take a look at this circuit, and specifically the question that I've had was, how can this cut the signal in half? Well, before we get into the circuit, it would be a good idea to review how the AUT1A, that's the triode tube that's in this radio, how that triode tube works, how it's built, and how it functions. This is the representation for the filament, and it's 5 volts, and I think it's a 1/4 amp also. So that's why it doesn't take long to heat up. And around this filament is the grid, and it's just a mesh of wires around the filament, and of course they are not touching anything. The filament doesn't touch the grid. And around all of this is the plate. This is the triode. And the 1920s representation, which is on the left there, of a triode, I think it would be better if we used this drawing, a more modern drawing of the triode tube, because it more accurately depicts how the tube is actually constructed. In other words, the grid is in between the filament and the plate. So this is the drawing that I am going to use in this circuit. It's the same circuit, just a more modern drawing of the triode tube. Now, how this triode tube functions is when the filament is heated, it can emit electrons if the filament is negative. And electrons move from negative to positive, so the plate is held positive. And if the grid is negative enough, the electrons can't pass through, or very few pass through the grid. And if the grid is less negative, then some electrons make it from the filament to the plate, causing current to flow in that tube. Now, if the grid is positive, we have many more electrons moving from the filament to the plate. So that means that the grid is controlling the amount of electrons that flow from the filament to the plate. And I also want to point out that the filament, the grid, and the plate are in a vacuum. So basically, the grid that's controlling the flow of electrons, the grid is a wire mesh in a vacuum. Well, what that means is the grid is very high impedance. So it will not load down a signal, or it won't load it down very much. We're talking in the meg ohms here for that grid. Now let's take a look at the circuit on the left. We know that the RF signal is going to be coming from the secondary of that RF coil that's all the way to the left, and it's going to pass through that .00025 microfarad capacitor. But what is that capacitor for? Or another way to think of this is, what would happen if that capacitor wasn't there? So I'm going to take it out. Well, we know the grid is very, very high impedance, but that coil is only a few ohms. And when you're trying to get energy from one part of the circuit to another part of the circuit, like here from that coil to the grid of the tube, you can transfer the most energy if the impedance match. Now here, without the capacitor, we have a huge mismatch. And basically the coil, since it's only a few ohms, even though it has energy and it is putting it on the grid, it's not very successful because of the mismatch of impedance. So let's put that capacitor back in. Now let's take a look at that resistor, that 2 to 4 meg resistor, known as the grid leak resistor. What would happen if we took that out? Well, again, we have a huge mismatch. And because that wire is just going right down into the battery, and if you trace it the other direction up through the filament, it goes to ground through a rheostat. So basically we're grounding out the signal. So that's why that resistor is there. We have now more successfully matched the impedance, and the signal is not going to be shorted out. Here is the circuit that detects and amplifies the signal because of the grid. It's obviously not a very big circuit, but it's very important. If we were to have a signal right here, we've got matching impedance, so it's not being drained away. When that signal is positive, we've got electrons flowing from the filament to the grid. And when that signal is negative, there is no flow because the electrons cannot flow in the other direction. So what has happened here is that signal is effectively cut in half. And here we have our signal, RF signal, coming in from the coil, passing through the capacitor, and at the grid, that signal is cut in half. I measured the grid voltage to ground, which is A minus and B minus, on my radio, and it read a positive 4.2 volts DC. Now we also have the signal on the grid, and that adds to and takes away from that bias voltage, the 4.2 volts. And that is what is now applied to the grid of the tube. and that is causing the electrons to flow from the filament to the plate. As the signal increases or decreases a little bit, so does that flow from the filament to the plate. Only much more electrons. That's where the amplification comes from. So what we have at this section of the circuit is audio, and the carrier that brought that audio to us is drained away by this bypass capacitor. And this audio, we've got an audio transformer. As the magnetic field increases and decreases with that audio, the magnetic field cuts across over to the secondary. And now we have pure audio at the secondary of that audio transformer. I hope this helps you understand the detector circuit of my 1923 Atwater Kent 10 radio. Thanks for watching.
CBS News. A MASH star is sharing a couple of pieces of TV history. When Alan Alda signed off as the wisecracking surgeon 40 years ago, he kept a couple of things to remind him of Hawkeye.
I am the love call of Evelyn.
Now the 87-year-old actor is putting the character's well-worn combat boots and dog tags up for auction. Deborah Rodriguez, CBS News.